Hello, everyone, and welcome to today's webinar on structuring governance in GitLab projects. My name is Sam Rakoub. I'm a staff solutions architect with GitLab. I believe you agree with me that as organizations grow and teams collaborate between projects and repositories, ensuring proper governance becomes critical. Governance is not about compliance only. It is about creating framework that empowers teams to work efficiently, securely, and with clarity. In this session, we will explore how GitLab enables you to establish the right structures for permissions, roles, workflows, and compliance policy. Sounds exciting, right? Let's dive into it. So, let's take an example structure for an organization. Usually in our organizations, we have departments. Under that, we have sub-departments, sub-departments, sometimes even, and projects. At the top level, executives set the objectives for the initiatives we are working on. Those objectives then they are translated into sub-objectives across these departments and then into tasks to be executed by the developers in each of these projects. In a healthy environment, any task a developer is working on in any of these projects should be mapped to an initiative or an objective defined at the subgroup and ultimately at the main department level or even at the organization level. In that way, we guarantee that all the tasks we spend our time and money on contribute towards the overall organization success. GitLab, things are organized in a sort of similar way. The work is organized in groups, which maps to the departments, if you like, subgroups, subdepartments, and then projects. The work itself is broken down into the epics, which are defined at the group level, sub-epics, which are defined at the subgroup level or the subdepartments level, and then we have issues, which are defined at the project's level and ultimately will be executed by the developers working in these projects. And then we can track our work by defining tasks or issues in GitLab at the project level, and then map them back or track them back against defined project roadmaps and project milestones, and ultimately against uh, group milestones and group roadmaps. Taking this structure into our example, we will have an organization structure, groups, subgroups, and projects. Of course, these are our departments, sub-departments, and projects. From there, we will define the epics, the initiatives. What are we working on as an organization, which maps into epics defined as the main group. And then we can even define, which is optional actually, sub epics map to sub initiatives at the sub departments level. And then we define tasks or issues in GitLab, which are mapped to these epics and the sub epics. The third step is to be able to track our work. So at the project level, we track our issues against the project iterations, the project milestones, the project roadmaps, and then we track that against the groups and subgroups, milestones, and roadmaps. That way, I have an end-to-end view of my work progress. An executive at the very top of the organization can literally see which task is delaying or accelerating the overall organization progress. And more importantly, any dollar spent in the organization can be can be tracked down to which initiatives it is supporting, and by the end of the day, we know how our budget and time are spent. Excellent. So now let's dive into the structure within the GitLab project. How can we put or ensure the proper governance and control on the code within our GitLab project? The first step, we need to understand what are the environments in our organization. Usually, I have seen it very common to have development, staging, pre-production, testing, and production environments. For our demo today, let's assume we have these three environments: development, staging, and production. That will map into branches in GitLab. We will have a branch per environment. which means that the development will be done against the development environment, and then changes will be propagated using merge requests, which we will see in a second, between these different environments. So we will create a branch per environment. Remember, what I'm describing today is just best practices, but you can combine them all in one branch if you like. So in our example here, I will create a branch for development, branch for staging, and a branch for production. Then the next step, and that is why we created the branches, we will define or set the owner per branch. This owner slash owners or group of people would be responsible to accept changes into these branches, target branches. The same way we have owners for our environments in the real life in our organization, we will set owners to our branches in GitLab. In my case, here, I have Mr. Newton as the owner for the development, Mr. Einstein as the owner for the staging, and Mr. Galileo as the owner for the production environment. Oh yeah, I didn't tell you that today I will have so many scientists helping me with the demo. In order to bring these scientists to my demo environment, let me overview. Actually, this is a good time to overview you on how I structured my demo. So in our example or in our demo today, because I will have an LDAP integration, I have decided to use my self-managed GitLab instance, which is deployed in my environment. And to show you how LDAP integration works and how I can bring these users in my demo, I will utilize an online available LDAP instance. So basically, this link would take me into this LDAP instance, which I have it opened here, and an online LDAP test server. The credentials to connect to this test server are available. So this is the server name or server URL and the port, and it's available, of course, for read only. And I have all of these scientists available in this online LDAP server. So basically, to integrate my GitLab instance into this LDAP server, what I have done, let me show you. It's very easy. You just SSH into your VM where the GitLab instance is deployed, and open the GitLab configuration file, which is available usually under ITSA, GitLab, gitlab.rb. If I open this one, and then there is a section for the LDAP server. If you like, pause the video here, and you can copy exactly the same configurations. It will work for you. Basically, I said I have an LDAP server. This is the label which I will see on my login page. The host for my LDAP, which is available here, and then the port and UID. Once you have that done, then your GitLab instance will look like mine here, the standard one, and then you will have another tab on the login page for the LDAP login. So now I can click on this LDAP, pick any user from here. Let's pick Mr. Einstein maybe, right? And come here and say, Mr. Einstein, and by the way, the password for everyone is password, as you hear. So just Einstein and password and login, and then I am logged in, right? So I have Mr. Einstein, there's this one, Mr. Einstein, don't save. Okay, excellent. So I'll log out for now, sign out for now. So I'll look back again as my root or the admin of the instance. Excellent, excellent. So now I will go back to the standard and log in back again as the root, so I can structure my project. So now let me go back to the demo environment. This is the group we talked about, and this is the project I will use today. And as I agreed before, we will have 3 branches, and we will assign Newton, Einstein, and Galileo to these as owners to these different environments using the protected branch feature in GitLab. So in my project here, under the code, just check that I have the branches defined. Yep, I have them here. Development, production, staging, or if you like, development, staging, production. By the way, creating a new branch, I've created them before, but creating a new branch is just about clicking on this one here, and you can name the branch whatever you like. Now, the next step is we want to map them against these different branches as owners. Excellent. So now I look back again as the root to my environment. Now, as I have the LDAP integration done, the next step would be to add these users to my group, right? This is how we do it usually. We add users to our groups or projects. So to do that, I have two options. Either I can come here under manage and on my group or project, if you like, and add these users individually by inviting them from the list, this list, or so I can come here and say, Mr. Einstein, you can come here and I want you as a developer and add him here. Or there is a better way. We have LDAP integrated anyway. So why not we use the LDAP synchronization feature in the GitLab groups? So if I click on or go back to my group, under setting, I have two things, LDAP synchronization and SAML groups link. Let's do the LDAP synchronization part. So basically what I'm doing here is that I'm saying I have LDAP integrated. I will use the LDAP user filter. I will use a filter that I have in my LDAP object class person, and I believe this filter is available here under the objects class. And if I want to make sure of that, I can come here and say LDAP stage, and this would give me all the users in my LDAP, and the password is password. Sorry, I typed it correctly. Sorry, I'll do it again. Password. And here we go. We have all the users. So basically what I will do is I will just use a simple thing, which is object class equal person. So basically I have an object class. What I'm saying here, can you please create for me an LDAP synchronization between the already configured LDAP for this GitLab instance to this group, and all the users who match this LDAP user filter, please add them to my group and give them developer role. And here we go, adding the synchronization. So now I have this synchronization already configured. Either I wait for this synchronization would happen automatically once per hour, or I can enforce it to happen now. So I can go under manage members and then click on sync changes. Yes, it will remove any direct members. Please remember this, because if you have any direct members, they will be removed if you have an LDAP sync, and click on this one and this will trigger the sync. Give it few seconds. And now, if I believe, refresh from here, yep, here we go. I have all the users who match the LDAP synchronization filter, which is basically object class equal person, added to my group. Awesome. So now I am ready to move to the next step. As we agreed, we will assign owners to the protected branches, development, staging, and production. Remember, if you have other branches, other users, you can always, and not necessarily to assign them by user. In my example here, I'm assigning them by user, but you can assign by group or even roles. Okay, let's do it. So for our development branch, our friend Newton will be the owner for that protected branch. So I will go back to my project now as I have the users already added and ready. And I'll go under my settings and repository, and then under protected branches, and then add a protected branch. And this is for my development. And the allowed to manage is Mr. Okay, let me copy his name, Mr. Newton. Should be here. Here we go. And allowed to push and merge is also only Mr. Isaac Newton. Excellent. Now we will do the same for other two. Mr. Einstein is also helping us today. Thank you. So we'll take his name, and he will be responsible for the staging environment. So I will add a protected branch and select from here Mr. Einstein, right? Einstein, yes, yes, and Mr. Einstein, and he will be responsible for the staging environment or staging branch. And last one, but definitely not least, Mr. Galileo will be add responsible for the production branch or environment. And Mr. Galileo, here we go. And there he, and then I will have him also for the allowed to push and merge Mr. Galileo. And here we go. And protect. What I have done here, I have mapped who is responsible, who is the owner for these branches. Only those people will be allowed to merge and allowed to push and merge, which means any change coming to these branches, which is environment, map to environment, would they have to come through a merge request, and those people who are the only people who are allowed to click on merge and merge the change into that target environment. Again, in this way, I am sure that no change will be propagated into these environments slash branches without the acceptance or without the action from these different users. Excellent. The next step from here is to define who is allowed to push, deploy, or if you like, the critical jobs in each environment. Basically, yes, someone is allowed to merge the changes into the pre-production or even the production environment. Then that will trigger a series of jobs in a pipeline to build and test the changes coming into that environment. But it is not necessarily that same person who accepted the changes would be the same person who's allowed to deploy the changes to the target environment. Simply, developers are working. Changes will come to the pre-production, to the development branch or environment, to the pre-production, and then to the production. Then in the production, I need someone also, not only to accept the changes, someone else maybe, to all say, okay, green light, I'm ready to trigger and deploy the changes. And this can be done using something called protected environments in GitLab. So I know we are using that word, the term environments interchangeably here, but please, these are two different things. In the first scenario, we have defined the different environments based on your environments, right? And we created branches for these environments, and then we assigned owners for these branches using protected branch. The second step is we will create, let's say, we will use the term or the feature called protected environments in GitLab. But basically, what I mean here is who is responsible, who will be allowed to deploy changes against these different environments. Basically, I will, in my deploy job, I will say this deploy is for the, for example, here is for the development environment. Mr. Riemann is the only person who can trigger the deploy or go to deploy that. For the sake of the demo today, I will use the same user Raymond for as the privileged person to click deploy across all of these different branches or pipelines. I know in the real world, I'm sure you will have different people, especially when it comes to the pre-production production, who are entitled or privileged to press and deploy and push the code to the target environment. To do that, let's go back to our environment here and go under CI/CD and then protected environments. As you can see here, I have three environments which I have protected before. Let me edit this and show you how, let me unprotect it and show you how you can do it yourself. So basically, first of all, you have to have the environments defined, right? And this can be done under operate environments. And then you can add a new environment here just as a term, as a word, as that's it. You define it and let's say sample, just an example, sample environment. And that's it. Actually, let me remove one of the environments I defined before, maybe development. Let me remove this one. stopped, removed, and let me create a new environment and call it development, right? And save. Yep, done. That's it. So now I can go back under my CI/CD here and protect these environments. So I can protect the environment, select development, and as we agreed before, we will use the same user, which is Mr. Raymond. If I can copy, sorry, if I can copy, let me copy it from here, which is Mr. Raymond, and say okay. Again, it's been added because of the LDAP sync and allowed to deploy and approver. And the same applies to the other two environments. So I have staging, user, Raymond added, and this one approver, this one added and done, and protect. And the third one is also production. Excellent. So I have three environments protected. So far what we have achieved, we have created branches, a branch per environment. And by environment, I mean your environment, whatever environments you have. And then we assigned using protected branches, we assigned who is allowed to accept and merge changes against each of these environments or branches. And then we use the term protected environments, which we will assign to these jobs so that I know exactly who's allowed to push and deploy the changes. In my case, deploy it can be any critical job you have, you want to have more control on. And in my case here, it is Mr. Riemann only. Cool, excellent. Okay, the third one, this is very important. Who should review my changes? Or in my numbering here, it's the fifth. It's very important here to distinguish between who is entitled to merge changes into the protected branches or protected environments and who should review these changes. In other words, I can be the owner of the production environment or production branch. I am the only person who's allowed to actually click and accept and merge the code into that branch. But I'm not the expert on all the changes and on all the code written in my environment. I need other people to review these changes and give their tick and green light before I accept and merge the code into the target environment. Clear? So these are two different things. Accepting the merge is one thing, which is done using protected branches, but assigning reviewers is a totally different thing. In our case today, again, we will use the same person to accept the changes coming into all of these different environments. And it is Mr. Goss. And again, I hope I'm pronouncing the name correctly. So what I will do now, we will need to define merge request approvals. Again, I will go under my merge request and say add approval rule. This is, let's say, development branch. And what I'm saying here, when there is a change targeting the development branch, please get the approval from Mr. Goss, save changes. And another approval rule, when there is a staging approval, when there is a change targeting the staging environment, this is what I mean by these lines here, a change targeting this environment or this branch, change targeting this branch, and so on and so forth. When there is a change targeting the staging, please use Mr. Goss as well. And when there is a change targeting the production, also please use Mr. Goss as well as approval. Excellent. So far, we have defined the branches protected. We have protected who can deploy against each environment. And now we have defined who should review the functional changes when I push changes from one environment or one branch to the next based on the target branch. Excellent. So this is defined, this is defined, this is defined, all good. The next one are our security friends. Mr. Ola is our security architect, security officer in the organization today. Remember, I've just said who should review in the previous scenario? Who should review the functional changes? Now, because GitLab is a DevSecOps environment, and we have security as an integrated part in the daily DevSecOps practice, security scanners, including the container dependencies, static license, secret detection, advanced SaaS security scanners, you can run them. And actually, we encourage that. You can run them against each and every change in your branch. Then you will get, as a developer, the scanning results for the changes you have done on that branch. So when you push your changes to be merged from your branch to the next environment or next branch, based on the security scanner's outcomes, the security officer, and in our case is Mr. Ola, will be added, based using the security policies, will be added to the approvers list on someone who should review your changes. Good? So now I know who is pushing. I know that who should review my changes using the code owners and the merge request approvals. And then now I'm defining who should, if required, this is very important, if required, who should review my changes from security point of view. So to do that, we will use GitLab security policies. So now I will go under my security policies. This is the next step, and define a new security policy. And there are multiple types of security policy. The scan execution policy is how you can enforce the security scanning. I've heard it before. What if our developers don't run the security scanning? How can we make sure that the security outcomes have been verified? And the answer is easy. You don't need to depend on your developers. You can use the security execution policy to enforce one or more security scanners against one or more branch in your environment. For our demo today, I will use the security approval policy, which is this one. Let's say security approval or security scanning approval, if you like. What I will do is when the security scanning runs against any of these protection, finds any one, any more than any vulnerability in my case, if there is any vulnerability with any severity, status in new or previously exist, right? This is select all, right? Then can you please get me the approval from individual users? And in my case, as I said, I'll use Mr. Ola. Cool. I'll just deselect these two because I may need to change that branch. And now I'll confirm the security, configure the security policy. And you will notice that now GitLab is taking me outside my project into the security policy project, because in GitLab, security policies are maintained in a separate project for segregation of duty. And now I'm merging it, and now I have a security policy defined. I go back to my project here. This is the security policy project. Now I have everything defined. Okay, excellent. So from here, it takes us into the analytics part, which is basically having an end-to-end view on what's happening in my DevSecOps lifecycle. GitLab provides a very comprehensive set of analytics capabilities, including value stream analytics, including CI/CD capabilities analytics, including the industry standards DORA or DevOps Research and Assessment Analytics. So basically, when I have all the proper controls, I would need an analytics of view or insights on what's happening in my platform, so that I would know if I'm having too much control or if I'm having a loosey control. Am I creating new bottlenecks by setting these governance rules? Should I move people around? Should I combine roles? Should I change roles or groups on who is responsible for what? In that way, I can make sure that whatever controls and governance I am setting, I am measuring the impact of that, so that I know that my overall DevSecOps is moving and progressing in a healthy way. Excellent. Which brings us now to the summary of all the roles and responsibilities we have done. So These are the roles or people we have used, or the scientists. Thank you, all the scientists who helped me during this process. And just as a reminder, so what we have done before is we have integrated our GitLab instance with the online LDAP server, and then we have used GitLab group synchronization to directly synchronize users from the GitLab, the LDAP server into our GitLab instance. And then we assigned those users different roles and responsibilities in our environment, between environment owners, between deployment owners, between code review owners, between security reviewers. And that's me, Mr. Tesla, who is the developer. So, okay, so now from here, let's see how our demo will look like, right? So what we'll do is I will log in as the developer. I will make a change. I'll try to push the change to the development branch. Shouldn't be able to do that. That's why I will create a feature branch where I will put my changes, then a merge request to push my changes into the dev branch. When I do the merge request, I should get the code review required and also the security, if there are any security findings, and also the security scanning approval from our friend Ola required as well, before our friend Newton be able to push the code into the target branch. So let's go into the issues, see if there is any issue. Okay, let me pick this issue here, and I will create a merge request for this issue. Now, by default, the created merge request will try to push my code into the main branch. So I'll change this because I want to push my code into the development branch, right? So this is it. I will create a merge request and okay, and I don't want to delete the source and create a merge request. Now, from here, I would try to edit the code using the web IDE. And here we go here. Okay, so I will update my CL file by adding the security scanning capabilities and also maybe a sample test job. Cool. So to add the security scanning, easy. I will come into my code and let's add the container, maybe the container, and I'll just come here. These are some of the templates provided. So I will keep the build. I'll remove these. I don't want to deploy that. Let's do remove this and just keep this. So build to build the container dependency scanning SAST. And also because I'm using the container scanning, I wanna my build job to run on any branch, not only on the main branch. So I will change this one or remove it so that it runs on everything. Also, because the container, I'm doing my own build job here, I don't need the build template included. And because the build job is pushing the code into this image, I will just define for my container scanning image. Please take it from, let me get the exact uh, page. Okay, container CS image, CS underscore image. Please take it from this one. Okay. So basically, Mr. CS image, take it from this is the image that I need you to scan. I have the container scanning. I don't need the dependency scanning for now. Cool. I think that should be enough. So what I'm doing here is I'm adding a couple of the security scanning capabilities provided, and of course, GitLab provides many other security scanning. Before I commit to our branch, let's do some testing here, my friends. I will change the branch and try to commit into the development branch. So see this one, it should not be allowed to push into that target branch. So I now I changed into the development branch. I remove everything and hopefully I should not be able to push. And yep, here we go. It says you have to create a branch for you to proceed because you are not allowed to push changes into that development branch. Thank you very much. I already have a branch created, so I have it here. I'll switch to this branch and I'll come here and say, okay, Control B, and hopefully everything should work. Okay, excellent. So my pipeline now is triggered, and it says here, this is your merge request. But by the way, your merge request requires approvals, two approvals, this one and this one. So should now log in as Mr. Goss and approve this one. So to do that, I will assign it to Mr. Goss as my reviewer and Mr. Ola as my other reviewer. Excellent. So let's keep the pipeline running here. So here I am logged in as Mr. Goss. You see here, I click on this one, right? And now if I click on assign merge request, I have one assigned review request required. So I can click on this one. And yep, here we go. I need to approve this change. Fine. Usually I may wait for the pipeline to finish, but now it's up. I can approve it. And now the pipeline finished. And now I need approval from our friend Euler, the security for the security scanning. Right. So again, if I log out from here, maybe yep, I'm logged in now as Euler. If I go under my assigned merge request, and if I go into this one, this is my assigned one, and now I can approve it. So now my merge request has been reviewed by everyone who should review the changes from functional, everyone who should review the changes from security point of view, and now my change is ready to be merged. Again, none of these users is allowed to merge. The only user who's allowed to merge is Mr. Newton. So if I look out from this one and log in as Newton this time, into the project, go to the project and into my merge request, you'll see that I should be able to approve this one, of course, after I remove the draft from, it is not a draft anymore. Thank you very much. Save changes, and now the merge request can be merged. Excellent. So just to summarize what we have done here, initially, we structured our project into groups and subgroups and projects. In our case, it was a simple group and project. We defined the environments for our deployments. And in our case, in the environments where development, staging, production, it can map to any different environments you have. And I'm sure most of you will have more of these environments. And then we created a branch per environment, right? Just a naming, a branch for development, staging, and production. Then we decided on who is the owner of this environment or these branches. So we use the protected branches to decide who is allowed to push code into these branches. Then to bring these users, we integrated the GitLab instance with the online LDAP server from sys, and we use the GitLab group sync to bring the users into my GitLab group. Then we decided on who should be allowed to push or click on the deploy job from each environment. And we use the protected environments to do that. So basically, we say, okay, these are the protected environments, and this is the person or people who are allowed to click on deploy. Then we decided on who should review the changes when we target each environment. So when I move code from feature into development, who should review the code? When I open a merge request from development to staging, who should review? And for all our scenarios, we used one user. Then we decided on who should review the code from security point of view in case there is a security finding in the code, whether an existing security finding or a newly uncovered security finding. And to do so, we defined security policies. And of course, we highlighted the importance of the analytics capability in GitLab because honestly, the, setting up a proper governance and compliance is one thing, and having an end-to-end analytics is another very important thing. And as I said before, GitLab provides an end-to-end analytics. These are the users we used for the different stages and different scenarios, and then we went through the demo. I hope this was useful for you. Please hit me if you need any help or any more details. Thank you very much.